MapReduce versus Apache Spark. Key differences and business use cases. In 2026, global data creation is expected to reach 221 zettabytes in 2026. At the same time, the global big data analytics market is valued at $447.68 billion and projected to reach $1.17 trillion by 2034. Companies are no longer competing to store the most data. They are competing to act on it fastest. Two frameworks have shaped large-scale data processing for years: MapReduce and Apache Spark. Both are open source. Both can run on commodity hardware or in the cloud. But they were built for different generations of data engineering, and in 2026, that difference has real consequences for speed, cost, and what teams can realistically build. This article compares MapReduce and Apache Spark across performance, development complexity, data processing capabilities, security, and cost. It also includes a practical checklist to help you decide which framework fits your workload. MapReduce Overview. MapReduce is a batch data processing framework first introduced by Google and later adopted as the core processing engine of Apache Hadoop. It breaks large datasets into smaller chunks, distributes the work across a cluster, and processes data in two stages: a map phase that transforms data into key value pairs, and a reduce phase that aggregates those pairs into final results. Its defining characteristic is that it writes intermediate results to disk after every stage. That makes it highly fault-tolerant. It also makes it slow. MapReduce strengths: handles petabyte-scale datasets on commodity hardware. Strong fault tolerance through disk-based checkpointing. Lower memory requirements, typically 8 to 16 gigabytes RAM per node, compared with 64 to 128 gigabytes for Spark Mature, Kerberos-based security model, built-in cost-effective for large, infrequent batch jobs. MapReduce limitations: heavy disk I/O creates significant latency at every stage. Supports batch processing only, with no native streaming or real-time capability. More manual to develop and lacks an interactive mode. Rarely chosen for new projects in 2026, with a shrinking pool of experienced engineers. Typical business use cases: MapReduce still fits log analysis, data warehousing, large-scale market research, and batch fraud detection in legacy financial environments, where speed is not the main concern. Apache Spark Overview. Apache Spark is an open-source unified analytics engine developed at UC Berkeley in 2009. Its core advantage is simple. It keeps intermediate data in memory instead of writing it to disk between operations. That single design choice creates the performance gap between Spark and MapReduce. Spark supports batch processing, real-time streaming, machine learning, SQL queries, and graph computation through a single API. By 2025, it had become the default platform for real-time analytics, AI model training, and cloud-scale data engineering. Apache Spark strengths: up to 100 times faster than MapReduce for in-memory workloads and up to 10 times faster on disk-based operations. Supports batch, streaming, machine learning, and graph computation in one engine. Multi-language AP is in Python, Scala, Java, and R Catalyst, and Tungsten optimizers support sub-second query performance on large datasets. Strong cloud integration across Databricks, AWS EMR, Google Dataproc, and Azure HD Insight. Larger and growing talent pool. Apache Spark limitations: typically requires 64 to 128 gigabytes RAM per node, which increases infrastructure cost. more complex to configure and optimize. Security is not enabled by default. Development complexity Spark provides AP is in Python, Scala, Java, and R, along with an interactive shell that speeds experimentation and debugging. MapReduce is more manual, less interactive, and often requires additional tools such as Apache Impala or Tez to reduce development friction, which adds additional operational overhead. In 2026, Spark engineers will be easier to hire and more aligned with the broader modern data tooling ecosystem. Engineers with deep MapReduce expertise are becoming harder to find. Data processing model Spark supports batch processing, streaming, interactive queries, and iterative machine learning in one engine. MapReduce supports batch only. Any streaming requirement adds another framework, such as Apache Flink, Storm, or Kafka streams, increasing operational complexity and creating more failure points. Security MapReduce includes Kerberos authentication and ACLs out of the box. Spark can be secured effectively, but it requires explicit configuration for authentication, encryption, and event logging. In regulated industries such as finance, healthcare, and government, this makes secure Spark deployment a design requirement from the start. Both frameworks are open source, so licensing is not the main factor. Infrastructure is. MapReduce nodes usually require 8 to 16 gigabytes of RAM. Spark production clusters typically require 64 to 128 gigabytes of memory, and memory-optimized infrastructure can cost 30 to 40% more than standard hardware. Still, the total cost of ownership is more nuanced than just hardware pricing. Spark finishes jobs faster, which reduces compute time. For iterative workloads, those time savings usually outweigh the hardware premium. In cloud environments, teams also benefit from paying for memory-heavy infrastructure only while jobs are running. MapReduce has an advantage only for very large, infrequent batch jobs where speed matters little. MapReduce versus Apache Spark side by side. When does MapReduce still make sense? MapReduce is rarely the first choice for new projects in 2026. Still, it remains reasonable in a few specific situations. Massive, infrequent batch jobs on commodity hardware where disk economics matter more than speed, stable legacy environments where migration risk and cost outweigh performance gains, environments that prioritize maximum fault tolerance on less reliable infrastructure. Regulated systems are already built around Kerberos, where extending MapReduce is simpler than redesigning Spark security. When to choose Apache. Spark is the better fit when the workload requires real-time or near real-time analytics. Machine learning at scale one platform for batch, streaming, SQL, and ML cloud-native deployment on Databricks, AWS EMR, Google Dataproc, or Azure HD Insight faster delivery, easier hiring, and interactive exploration. Iterative workloads, where the same data is accessed multiple times in one job. Alternatives worth considering MapReduce and Spark are not the only serious options in 2026. Apache Flink. Best suited to stateful stream processing with exactly once guarantees and very low latency Google BigQuery. Strong fit for serverless SQL analytics without cluster management. Snowflake, optimized for multi-tenant, high concurrency data warehousing. Databricks, a managed Spark platform with Delta Lake, ML Flow, and collaborative notebooks. In many cases, the more important question is not just which framework to choose, but where Spark should run, which storage layer should sit underneath it, and whether another platform is better aligned with the workload. How to choose. decision checklist. Choose MapReduce if the workload is large-scale batch processing with no real-time requirement. Cost is the main constraint, and disk storage economics matter most. You already run a stable Hadoop environment where migration risk outweighs the upside. Your security model is built around Kerberos. The workload is non-iterative, with data read once, processed linearly, and written once. Choose Apache Spark if real-time or near real-time results are required. Machine learning or iterative analytics is part of the workload. You want one platform for batch, streaming, SQL, and ML. You are building on cloud infrastructure developer velocity matters, including faster delivery and easier hiring. The workload is iterative, with repeated access to the same dataset. Consider alternatives if stateful streaming with exactly once guarantees is critical. Apache Flink. You want serverless SQL analytics without managing clusters. Google BigQuery. You need multi-tenant, high-concurrency data warehousing. Snowflake. You want managed Spark with integrated ML and storage tooling. Databricks. Why Inoxoft for big data engineering? Choosing the right framework is one decision. Designing the architecture that actually fits the workload is another. Inoxoft has delivered data science and analytics solutions for more than 10 years across MapReduce, Spark, Flink, Databricks, and cloud-native platforms. We evaluate each client's pipeline based on actual data volumes, latency requirements, team capabilities, and existing infrastructure, not just what looks best on paper. Why data engineering teams choose us: deep framework experience, real-time streaming pipelines, ML lib-based model development, legacy MapReduce migration programs, and cloud-native data platforms across AWS EMR, Databricks, Google Dataproc, and Azure HD Insight end-to-end delivery. Pipeline design, data ingestion and transformation, model training and deployment, and production support handled by the same team, from scoping through launch compliance by architecture, ISO 27001 certified, with security and auditability treated as design requirements from the first sprint. Engagement flexibility, dedicated team, project-based partnership, or staff augmentation, depending on what the project needs. If your team is evaluating data pipeline architecture, the best starting point is a clear understanding of what you need to process, how fast, and at what cost. Final thoughts. MapReduce was the right answer for a long time. In some environments, it still is. But for most organizations building or modernizing data infrastructure in 2026, Spark is the stronger choice across performance, flexibility, talent availability, and cloud alignment. The organizations creating the most value from data are not the ones storing the most of it. They are the ones acting on it quickly. MapReduce was built for a world of overnight batch jobs. Spark fits the world in which most businesses operate. The right decision starts with the workload. Inoxoft helps organizations evaluate that choice and design data architectures that match real operational needs.